Good morning dear viewers. Welcome to our today's session for online classes. I hope that you all are doing well. So let us begin. In the last lesson we had seen exercise 1.1. Today we will start with properties of addition and subtraction of integers. So in that we will see closure under addition, closure under subtraction, commutative property, associative property, additive identity. After that we will see exercise 1.2. Okay, so let us begin. Our first property is closure property. First property is closure under addition. Closure under addition. If a and b are any two integers, a and b are any two integers, then if we add a plus b, then whatever answer we will get, then a plus b will be also an integer. For example, let us take 17 plus 23, that is equal to 40. Okay, if you take minus 10 plus 3, the answer will be minus 7. So this is also an integer. This is integer, this is also an integer. So if you take one more example, minus 35 plus minus 10, the answer you will get is minus 45, so which is also an integer. So it will be true for all values. Okay, so here we find that integers are closed under addition. Okay, so in general we can write that, in general we can write for any two integers, a and b, a plus b is an integer. So you take any two integers, take any two examples and then add them together, and whatever answer you will get, the answer will be also an integer. So from this we come to know that integers are closed under addition. Integers are closed under addition. Okay, next property is second one, closure under subtraction. So that is closure under subtraction. So let us take examples. 7 minus 9, that is equal to minus 2. So this is also an integer. Minus 2 is an integer. So take one more example, 32 minus 17. So this will be what? 32 plus 17. Minus into minus becomes plus, minus multiplied by minus becomes plus. So 32 plus 17, that will be equal to what? 49, which is also an integer, Okay, so what do we observe over here? That whenever we take difference of any two integer, then the resulting answer, whatever we will get, will be also an integer, Okay, so from this we come to know that integers are closed under subtraction. So integers are closed under addition and integers are closed under subtraction. Okay, so this was the closure under subtraction property. Next, our third property is commutative property. Okay, so what is commutative property? Commutative property. So what is commutative property? Commutative property states that a plus b is equal to b plus a. If you add any two integers in any order, okay, then the answer will be same. For example, let us check. Let us take 2 plus 3. This will be equal to 3 plus 2. Let us check it. First LHS, that is equal to 2 plus 3, that is equal to 5. Okay, now let us check RHS. 3 plus 2, that is equal to 5 again. Okay, so 5 is equal to 5. So here LHS is equal to RHS. So from this we come to know that a plus b is equal to b plus a. Okay, so you can check it for any value. Okay, we will see one more example and then we will conclude. Let's take negative numbers. -1 plus -3 is equal to -3 plus -1. So here what we have done, we have changed the order of the numbers. First we have taken -1, then we have taken -3, then here on the right hand side we have taken first -3 and then we have taken -1. So -1 -3, this will become minus, plus into minus become minus, -3 -1. Okay, this will be -4 is equal to -4. So here our LHS is equal to RHS. Okay, so from this we can conclude that a plus b is equal to b plus a. This is the general formula. Okay, so we can say that addition is commutative for integers. Addition is commutative for integers. Addition is commutative for integers. Now let us check if a minus b is equal to b minus a, if it is correct. So I think that this will not be true. Let us verify. A minus b, b minus a. Let us check it. Okay, what our answer comes, whether it is equal or not. Let us take one example. 5 minus 1, and on this side we will take 1 minus 5. Now let us solve LHS first. So 5 minus 1 is equal to 4. Now let us solve this RHS. That is 1 minus 5. 1 minus 5. So here you will do subtraction. Here you will subtraction. Opposite signs are there. So here you will do subtraction. Okay. So now 5 minus 1 is 4. But here 5 is bigger. So 5 is carrying negative sign. So we will write here negative 4. So 4 is not equal to negative 4. So this is not equal. This is not equal. This is not equal. So here also this is not equal. So a minus b is not equal to b minus a. So from this we conclude that subtraction is not commutative for integers. From this we conclude that subtraction is not commutative for integers. Addition is commutative but subtraction is not commutative. Now till now we have seen three properties: closure under addition, closure under subtraction, and commutative property. Okay, so closure under addition is what? If you have two integers and if you add them, whatever answer will come will be same, will be an integer, will be also an integer. closure under subtraction. So if you have any two integers a and b, and if you take difference of those two integers, then a minus b will be also an integer. Okay, so closure under addition, closure under subtraction, and third property is commutative property, that is a plus b is equal to b plus a, which is true for all values, but a minus b is not equal to b minus a. Our next property is associative property. So let us check it. Associative property. So associative property is what? A plus into bracket b plus c is equal to into bracket a plus b plus c. So here we are having a plus into bracket b plus c is equal to a plus b into bracket plus c. Okay, now let us check this, let us verify this. So this is associative property. Okay, now let us check. 1 plus 2 plus 3 is equal to 1 plus 2 into bracket plus 3. Now first we will solve LHS and then we will solve RHS. Okay, let us solve LHS first. That is 1 plus, so here according to BODMAS rule, first we will solve the bracket. So 2 plus 3 is what? 5. Okay, so 1 plus 5 is what? 6. So here we got LHS as 6. Now let us check RHS. First we will solve the bracket. We'll use the BODMAS rule. Okay, 1 plus 2 is what? 3 plus 3. 3 plus 3 is again 6. So from this we can conclude that LHS is equal to RHS. And you can take any value, any integer. Put here any integer, but it should be a should be same on both the side, b should be same on both the side, and c should be also same on both the sides. Okay, and then so from this we can conclude that if a, b and c are any three integers, then a plus into bracket b plus c is equal to a plus b into bracket plus c. So this is associative property. Our next property is additive identity. Additive identity. So additive identity is what? When we add 0 to any integer, the answer will be the same integer. When you add 0 to any integer, the answer you will get is the same integer. Okay, 5 plus 0 is equal to 5. 6 plus 0 is equal to 6. Okay, 0 minus 8 is equal to minus 8. Okay, if you add 0 to any number, the answer will be that same number, that same integer. Okay, same integer. So this is the additive identity. In general we can write it as a plus 0 is equal to 0 plus a is equal to a. Okay, so this is additive identity. So these are the properties of addition and subtraction. So in this, what we have seen up till now: closure under addition, closure under subtraction, commutative property, associative property, and additive identity. Now we will see exercise 1.2. So now let us solve exercise 1.2. Okay, so our first question is, write down a pair of integers whose pair, here pair means 2. Okay, so first one we have given sum is minus 7. Okay, so write down a pair of integers whose sum is minus 7. Okay, pair means 2, sum is minus 7. So here we will take minus 5 plus minus 2. Okay, so here what do we get? Minus 5 plus into minus minus 2, that is equal to minus 7. So this will be minus 7. So here we got minus 5 and minus 2. again you can have many pairs. Okay, for example, you can have -6 plus -1, so you get again -7. So like this way you can write. Okay, so this is second example. Third one is again you can have -3 plus -4. Okay, so -3 minus 4 is equal to -7. Okay, so you can have various values, okay, whose sum is -7. Next, B, difference is -10. Okay, difference is -10. So let us take 6 minus into +4. Okay, into +4. So -6 difference, here difference means subtraction. Okay, so minus then 4. Okay, -6 minus into bracket +4. It is not -4, it is +4. Okay, so -6, when this bracket will open, this will become again minus, this will be -4. So -6 minus 4 is what? -10. Same sign, what you have to do? Addition. Okay, though it is minus sign, but still you have to add them and you have to give common sign. So we got -6 and -4. Like this way, again many examples you can have. Okay, so this was B. So C, sum is 0. So we can have -3 plus 3 is equal to 0. Okay, -2 plus 2 is equal to 0. -1 plus 1 is equal to 0. Okay, -100 plus 100 is equal to 0. If you take a number and if you add the additive inverse of that same number, then the sum, whatever answer you will get, will be 0. Okay, for example, -a plus a is equal to 0. So this is in general we can write. Okay, so this was our first example. So next, our next example is second one. Okay, write a pair of negative integers whose difference gives 8. We have to write a pair. Okay, pair means 2. Okay, so now here we have to write a pair of negative integers whose difference means subtraction. Difference means what? Subtraction. Gives what? 8. So let us take -2 and -10. So -2 minus into -10. So -2 minus into minus plus 10. So -2 plus 10. So whenever there is opposite sign, at that time you have to do subtraction. So this will be 10 minus 2. This will be 8. So answer is 8. You have to do always subtraction. 10 minus 2 is 8. So which number is bigger, 2 or 10? 10 is bigger. So 10 carries positive sign. So this will be also carrying positive side, but generally we don't write. So here we got the answer. Okay, second one, B. Write a negative integer and a positive integer whose sum is -5. So write a pair of negative integer and positive integer whose sum is -5. So let us take -6 plus 1. So this will give us -6 plus 1 is what? 6 minus 1. Whenever there is opposite sign, at that time you have to do subtraction. Okay, so 6 minus 1 is what? 5. So 5, but 6 is the bigger number and it carries negative sign, so it will be -5. So this is our answer. Okay, so next question is, write a negative integer and a positive integer whose difference is -3. So we will take -1 and 2. So -1 minus into 2. So -1 minus 2 is equal to -3. Okay. So our next example is, in a quiz, team A scored -40, 10 and 0, and team B scored 10, 0 and -40 in 3 successive rounds. Which team scored more? The next part of the question is, can we say that we can add integers in any order? So here we are having team A scored -40, 10, 0. Okay, so let us add the scores. So -40 plus 10, this will be -30. Okay, so this will be -30. So team A scored -30 marks. Okay, so let us check of team B. Team B scored 10, 0, -40. So let us add these values, 10 plus 0 plus -40. So this will be 10 minus 40. Okay, 10, 0, 0 will be omitted. Okay, plus into minus becomes minus, so -40. 10 minus 40 is what? 40 minus 10 is what? 30. And 40 is bigger number, so 40 is carrying negative sign, so here write minus. So -30. So both the team score are equal. Team A score is equal to team B score. Okay, so next part of the question is, can we say that we can add integers in any order? You can say yes, because of commutative property. Okay, so this was our third question. So next, fourth one. So I have written down the questions. -5 plus -8 is equal to -8 plus dash. What will come? So here -5 plus -8. So on the LHS we are having -5 and -8. On the RHS we are having -8. Okay, so which number is missing? -5 is missing. So here we can write -5. Okay, so which is this property? Commutative property. So here -53 plus dash 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 is equal to -53. Which number will come? 0 will come. Okay, so we can write here additive identity or zero identity. Okay, third one, 17 plus dash 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 is equal to 0. So here if we write -17, this will become 0. Okay, so here we will write additive inverse. Okay, 13 plus -12 plus dash 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 is equal to 13 plus into bracket -12 plus -7. So which number is here? -7. So we can write here -7. So this is associative property. Last one, -4 plus into bracket 15 plus -3 is equal to -4 plus 15 into bracket plus dash dash dash. Which number will come? -4 and 15 are already there, -3 is missing, so here it will be -3. Okay, again associative property. Okay, so we have solved the filling the blanks. -5 plus -8 is equal to -8 plus which number was missing? So -5 was missing, so we wrote here -5 by using commutative property. Okay, -53 plus here was the dash. Okay, so here which number will come? If we add 0, then the answer will be -53, same answer. So additive identity or zero identity. Okay, third one, 17 plus here it was dash is equal to 0. So when we add additive inverse the same number, then we get the answer as 0. So here -17 is what? Additive inverse of 17. Fourth one, -13 plus into bracket -12 into bracket plus -7 into bracket is equal to 13 plus bracket into bracket -12 plus into dash dash dash. So here it was -7, so here we took -7. Okay, so This was by using associative property. So here we will finish our lesson. Okay.